So quick show of hands before I get started to help me know what slides I can skip and which ones I have to talk about. How many people were either A, here for the previous session, or B, have a reasonable understanding about what identity on distributed ledgers is? Perfect. I will run through some slides faster than normal. All right, so who am I? My name is George Fletcher. I'm the identity architect at Verizon Media. If you're wondering what in the world is Verizon Media or how does Verizon Media fit into Verizon, Verizon Media is effectively the merger of AOL and Yahoo and all of their associated brands, right? So that includes TechCrunch, Engadget, Riot, a whole plethora of brands. So I'm responsible for the consumer side and the business side of our identity stacks at Verizon Media, not the wireless and wireline for those who might have specific questions about your mobile phone plan. All right, so super quick, right? The concept of identity from a distributed ledger perspective is how do we make it a little bit more like the real world? How do we make it like a wallet where I can take my driver's license out and show it to somebody to prove my identity or prove I'm over 21 and move that into something that we can carry around with us that's a digital agent of some sort? It follows this kind of a model. You have an issuer who issues verifiable credentials, and they issue them to me. Right? And then I can present them to some party called a verifier, and that proof proves not only that I'm the one presenting it, but it's also I'm the one that the issuer gave it to, right? So there's sort of a proof of possession, a cryptographic chain all the way through, and the verifier can basically look at that cryptographic proof and say, yes, that issuer gave it to George, and so therefore I can trust it. Without necessarily having to go all the way back to the issuer to say, is this still valid? And so there's some aspects of some privacy benefits in that kind of a model. So what I sort of want to focus on today, because it relates to relying parties, and I'm looking at this, right, AOL, Yahoo, our identity stacks, right, we do identity for relying parties. And so what does it mean if we were to support self-sovereign identities in this kind of a way? And in the sort of identity on the distributed ledger model, you have this thing called a DID, and for those of you who are here, you saw a great explanation of this. The key elements here are that a DID is universally resolvable into a JSON blob, the part on the right, and that JSON blob contains a public key. So if you consider that your agent generates a public-private key pair, associates effectively the DID with a public key by registering it into the distributed ledger, then it's possible for someone else who has the DID to resolve that and get the public key. And therefore, if the agent signs some data with its private key, you can validate that the holder of the private key signed the data and it matches the public key of the DID. All right, that all makes sense? So there's your 3-second interview. Oh, my clock didn't start. Overview of distributed ledger technology and identity. All right, so what relying party? So let's look at relying parties and what does that mean? One thing that we sometimes forget is that relying parties have an identity lifecycle they have to manage, regardless of whether they're doing the identity themselves or they've outsourced it. And this isn't a complete, exhaustive lifecycle model, but it sort of highlights a few key things that I want to cover today. When some random person shows up at my site and I'm the relying party, right, I need to onboard them so that they can use my service. Right? If I'm coming into Spotify, I need to have a way to associate what their favorite kinds of music are with that identity, right? So there's an onboarding process, right? When the user comes back, I need to have a way to ensure that it's the same user that was there before, right? So that I can connect them to their appropriate, pre-saved playlists. right? Sessions can get revoked. I can lose my authentication credentials in some way, right? Today we think about that as I forgot my password, but it could be any other mechanism, right? If I'm authenticating via my phone, via push message, and I lost my phone, I'm in the same sort of boat. So how do I recover and get back to my identity at the relying party? And then, of course, at some point in time, either through inactivity or user self-delete as required by GDPR, right, the identity can get deep provisioned and no longer be part of the relying party. In some cases, it may still be there for legal reasons, like if you bought something and they have to keep the records for 3 years or whatever, but you get the idea. So one of the key things that has to happen, or let me back up a little bit. It's super important if a relying party is going to support something like self-sovereign identity to basically create an indirection between the core identity and the attributes and effectively the authentication methods that are going to authenticate that identity at the relying party. And I'll go through a couple of examples here, but in the case of self-sovereign identity, don't take the DID and make it your primary key in your database is sort of one of the things here. And you'll see why as we go through this talk. Right? Create your own identifier for that user. And the reason is there may be multiple ways that that user wants to authenticate, right? Maybe there are multiple things that can authenticate them besides just DID authentication, which we'll talk about in a minute. So in this kind of a model, then, I can associate with my relying party ID the fact that some user named GF Fletch, and you'll see how that got entered in a minute, authenticates via a self-sovereign identity using a DID-auth authentication method, and the identifier for that flow is a DID, right? If I'm doing OpenID Connect, I might have a subject value. If anybody's familiar with OpenID Connect has the same sort of mechanism as a DID. You have an issuer and a subject, right? So I can put my issuer in the IDP, and I can put my subject in the username or my subject in the credential. And again, I had this linking that both could link to the same relying party identity. All right, so we good there? All right, so let's talk about these flows, right? In registration, right, normally today you come to a registration endpoint and you've got to fill in a bunch of stuff, right? So you fill it all in. It could include things like when I went to sign up for Airbnb, scan your driver's license on both sides, right? So it could be doing all sorts of stuff, but effectively you are interacting with the relying party. It's collecting data, right? In many cases today, get your phone number, send a code to your phone number, verify the phone number, and now you're onboarded into the system, right? And somewhere in there, you give a password. So what does a sort of self-sovereign identity registration flow look like? Well, if you think about it, we have a DID. The DID's associated with a private key that's known only to the user. It's made the public key available. Effectively, what you're doing from a registration perspective is you're saying, I'm going to prove that I have ownership over this DID. So there's I can't call it a spec. There's ideas called DID authentication, last published for the Web of Trust in July of 2018, that basically have a challenge message and a response message. So what this looks like is you can put the challenge message in a QR code, have the user take their wallet on their phone, scan the QR code, which effectively reads the challenge message into their phone, process it, sign the response with the private key, send it back. So sort of like this, right? And now if I want, as a relying party, to request additional claims, I can send a UI back to the browser, ask for additional claims, right? Get those claims, and now the user's created in my system. And I'll tell you why I have an additional claim there in a minute. But so that's generally the flow. So there's a couple of things here that become different from what we do today. One, if you were here at the last session, you heard Preeti talk about basically wanting to post a verifiable credential of her salary and her title to a bank for a loan process, right? So in that authentication response, I can provide verifiable claims. The problem is that as a relying party, I don't know what the other person has in their digital wallet. So in this particular case, Capital One has a great slogan for this that I probably shouldn't use for copyright violation reasons, but you all have seen the commercials and you know what I'm talking about. As a relying party, I have no idea what's in that person's wallet. So how do I ask for claims? How do I ask them, please, give me first name, last name, date of birth, right? Because that's what I need for my sort of generic service on the web. How do I ask them for, I need a verified driver's license, or I need other data that would give me an identity proofing at a much higher level, right? Because I'm a bank or a financial institution. I also don't have any idea within the person's wallet whether they have a verified claim or a self-asserted claim. So if I need a verified date of birth, how do I ask for that? And finally, anybody can put a verified claim in the wallet, right? So who do I trust to give me verified claims, right? So there's another trust element. And so if I ask for, please give me a verified date of birth over 21, and I get it back from hacker's bank at Russia.com, should I trust it? Maybe I should, maybe I shouldn't, right? But how do I know? So there's a lot of things here. And then finally, there's a lot of talk in the self-sovereign identity space around it's privacy preserving because you only push the stuff you want. However, when we rolled out OpenID Connect, the two things relying parties wanted was effectively an email address and a phone number. I want a way to communicate with the users. And it's going to be really, really interesting to see whether Apple can pull off their pseudonymous email address thing with Sign In with Apple, if you've looked at that at all, and actually get it to work in the ecosystem. Because I don't think relying parties are going to like it. And I think Apple knows relying parties are not going to like it, so that's why they're mandating that if you do any sort of social login, you must add them as one of the social login providers. Otherwise, your app will not get published on the App Store. So effectively, I have to use my heavy hand to get people to adopt it. And then at the protocol level, basically, SSI is pretty much a federation flow. The problem is that there are over 20 different DID methods registered. So I didn't really talk about this, but if you're familiar with it, a DID consists of DID colon, a method, and then the unique ID. The method basically determines how that's resolvable and a whole bunch of other stuff, what goes in the JSON object that you can resolve, etc. There's 20 of those. Everybody's DID authentication challenge response is effectively different today. So there's a lot of standardization work that has to happen here to make it viable for relying parties to adopt. All right, authentication. I chose this. This is basically a standard app push authentication method that we use with Yahoo. Enter your username. We know that your username is that you've basically signed up for app push. So we basically push the challenge or are you trying to sign in to the app. You basically click that yes button. So the two on the left are in my browser. The two on the right are on my mobile device. I click yes. Mobile device tells me I'm signed in. My browser, shows me my mail. So the authentication mechanism for SSI is pretty much can be similar to what we showed with registration, because again, remember, whether I'm registering or whether I'm proving or whether I'm authenticating, I'm effectively proving ownership of a DID by signing some piece of data with a private key associated with the public key in the DID document. So, show a QR code, scan the code, post the authentication response, right? The browser updates that you're signed in. So the main difference here is that we're not asking for claims, but the flow is the same. However, if when I registered, I asked you for a username, and I got you to give me a unique username, now I can actually do a flow that's very similar to what you saw in the push mechanism. And that would work like this. I go to the browser, it says enter your username. I enter my username, right? And basically, when you give the username back to the relying party, I go to my table, I look up that username, I go, oh, it's associated with this DID. I resolve the DID, right? Which includes also services, which could be, here's the authentication endpoint, and now I can basically push the authentication challenge directly to the wallet, or more likely to the user's agent that would then eventually get it to their phone, right? And so in this context, right, I enter my username, my phone wakes up, I answer something on my phone, I'm logged into the website. So again, basically, the identifier first flow, if we implement it that way, can make it very similar to what we have today. That might be good for relying parties, a similar user experience, maybe good for users. The biggest issue here, I think, is that there's a lack of standardization. So there is the Decentralized Identity Foundation that's working to build standards, and there's a lot of work there that we need to do. All right, so let's talk about account recovery. The funnest thing that happens with new identity systems is that we always solve the authentication problem first, and we forget about account recovery. And it's not to say that SSI has forgotten about account recovery, but it's pretty important to think through what does this mean from a relying party perspective, not from a user perspective, though it affects the user. So this is, standard one, enter your email address. We look up your email address. We find some other communication channel that you have. We, send you a verification code to your phone number, or whatever, and you get logged in. Now, in the SSI world, and this is a little bit tongue-in-cheek, right? But kind of the SSI world is don't lose your private key as your recovery method. And I don't think that's going to work for relying parties. So, what do we do here in this context? As a relying party, what other mechanisms do I have to help a user recover their relationship with me? It may have completely nothing to do with them recovering the verified credentials inside the wallet on their mobile device. That's a whole nother problem. But I can put my relying party hat on and basically say, I need that user back into my service. Maybe they're paying for it and I don't want to give them a credit, right? I need them back into my service regardless of what happens, if they lost their phone or their backups got lost or whatever else. So the big question here from a relying party perspective is, what are the implications of allowing other recovery methods? If you think about it, a private key, public key, cryptographic mechanism for authentication is a pretty strong one. Right? Provided the user's doing a decent job of keeping their private key private, that's a pretty strong authentication method. So what are the other recovery mechanisms that I can give them that would equal that level of strength? Otherwise, the attackers will go after the recovery method because they can get access into that user's data at my site, regardless of, they don't have to worry about trying to hack my private keys. All right, that started late, so I need to hurry. So some other things I wanted to talk about, account linking, right? What does it mean? We're going to run both traditional mechanisms and SSI mechanisms in parallel for a long time. So assuming I already have a Spotify account, but now I want to log in with my new cool digital wallet, right? What does that mean? Right? And if I link my digital wallet to my Spotify account, that authentication process may be stronger than my current password with Spotify. And in that context, right, should the user be required to upgrade their non-SSI authentication mechanism to an equal level of strength or not? These are all questions as relying parties we have to ask. Is this something, how are we going to manage that? How are we going to help a user? Right? Because otherwise, if it's not easy for a user, if it doesn't make sense for a user, they're not going to do it, right? We spend in Verizon Media a lot of time tweaking the user experience and measuring to see, did that have a measurable impact in improving the user flow? Yeah, and as soon as you get into account linking, when should you link is another fun question. So There's a couple of interesting things around fraud and anti-abuse, and I apologize for the spelling mistake there. One, it's a whole brand new technology. So therefore, there's a whole ton of new attack vectors that haven't been exploited, figured out, understood, and mitigated. So that's one aspect of it. But the other is, effectively, what SSI provides is cryptographic trust. Now, there are organizations like the Sovereign Organization that's looking to put a governance framework on top of the cryptographic trust to try and help with this. But just because somebody comes to me and gives me a verified credential that they have a bank account at Capital One does not necessarily mean that it's not fraud against my relying party. And so you can't just assume that just because you got a verifiable credential that therefore there's no fraud. So relying parties still have to deal with the fraud question, understand it. It may help mitigate it. For sure, at AOL, when we basically deployed, you must verify a mobile number in order to create an account, it dropped the fraud rate, but it did not eliminate the fraud rate by any stretch of the imagination. Now, there are a couple of things I think that are really interesting about DIDs. This ability to expose the services associated with the DID is an interesting aspect that we don't really have today, right? That a given identifier can expose services. Now, you could say, well, maybe an email address exposes their email provider, but it doesn't give you a generic set of services that could be associated. So we talked about a service that would allow you to push an authentication method to the user to challenge them, right? But you could also have a generic communication method, a generic communication service that you could put there. You could put a query mechanism for those who are here in the previous talk that would say, I want to sort of in real time ask you for your current address, right? So I don't, as a relying party, might not have to store your address. I will just ask whenever I need it because I can figure out where the endpoint is to make that request and in real time by basically doing DID discovery. So I think there are some interesting aspects to the model here besides just the sort of elegance of the cryptographic model that has been invented. So some final thoughts. Basically, as relying parties, we're going to have to support both identity models in parallel. And when we need to support SSI is probably a big question. Is it 1 year? Is it 2 years? Is it 5 years? Is it never? We'll have to see. We need to minimize the infrastructure impact. So that's where sort of separating the sort of credential representation from your underlying identity is super important because that minimizes the impact of the model of SSI against what you do internally. And then there's tons of innovation and lack of standardization within the space that if you want to adopt early, it'll be a bumpy road. That said, for those people who have sort of interacted with me, I've been a bit of a naysayer. And in working through this talk, I sort of got to the point that I think it's viable. Whether it solves all the problems that are claimed, I still question. But I do think there are aspects of it that are useful, and we will likely need to support it at some point in the future as relying parties. So with that, thank you very much, and I'm happy to take a few questions if we have time. Sure.
As a relying party, so long as you can get validated attributes and robust authentication mechanism through some other identity, do you really care if it's self-sovereign or not?
No. I think as a relying... Sure. The question is, as a relying party, if you can get verified attributes and a consistent authentication mechanism for an entity, right, that could be strongly identity-proofed attributes or weak, right, depending on what you need as a relying party, does the relying party care? And thank you. Does the relying party care whether it's self-sovereign identity versus something else? And I think from a relying party perspective, the answer to that is no, we don't care. Right? We want that basically strong authentication that you're the same person that you were before. We want to be able to mitigate fraud. And in certain cases, depending on the relying party, you may need stronger verified credentials in that process. How you get them probably doesn't matter. This was sort of slanted from the buzz that's happening in the community in the identity sort of community right now. Anything else? Yes?
That ties back to the earlier thing that you stated, that who do you trust as your issuing authority, right?
Yes.
So how does, I mean, what are the guidelines? Are you saying that I'm going to trust the DMV but not?
Well, I think for any given relying party, right, you get to make those rules as to who you're going to trust, right? Whether that's a sort of trust framework model where a bunch of banks get together and say, right, as long as we all agree to these standards, anybody who's part of this trust framework, I will trust any one of those, right? You can take that kind of an approach. You could be very specific. You could say, I don't really need any verifiable credentials at all, right? I don't need any verified attributes. I just need you to tell me something and give me an authentication method that's reasonably strong so that I can connect you to you when you come back. And, so for a lot of, an open table, AOL, Yahoo, right? Self-asserted is fine, right? Yes?
Does DID how the authenticator apps work? Google and Microsoft's authenticator apps?
So the question is DID how Microsoft and Google authenticator apps work? And the answer to that is no. There really isn't any, there are proof of concepts, like there's a CU Ledger, which is a consortium of credit unions, have a wallet that uses DIDs for authentication. But the authenticator apps from Google and Microsoft have largely been something called time-based one-time password mechanisms. Microsoft may have some DID stuff in their most recent authenticator app. And there's lots of Microsoft people here you can ask. I don't know that for sure. But in general, the authenticator apps as they've existed have been based off a standard that exists for time-based one-time passwords. All right. Thank you all very much.